This is Professor Derek Seitz, Trigonometry Functions. This section here shows the graphs of the trigonometric functions. We'll be seeing all of them. They're also known as circular functions. Let's analyze these very carefully. Remember the unit circle tool. As you take and you increase the angle as it goes around the circle, the cosine and the sine are the coordinates of the point on the perimeter of that circle. And as you go around one revolution and you go again, the same points are traced out. The biggest the x and y ever get is 1. And if we look at these graphs, notice that here we have f of x is the cosine of x. The largest it ever gets is 1, and the smallest is -1. And it matches what happens as you go around the unit circle as the angle gets bigger and bigger, positive or negative. That's what the x-axis is here, the angle. And the y is the function value of cosine. And notice we have a wave pattern, a periodic function. And they're called circular functions because they originate fundamentally from the unit circle going around it. The sine is very similar, but it's a little shifted off from the cosine, of course, because it's the y-coordinate and not the x-coordinate. But besides that, their shapes are the same. And many things in the natural world follow a periodic pattern, such as the tides coming and going, and waves in the ocean, and electromagnetic radiation, light, and electricity, and so many different things can be studied and modeled using trigonometric functions. And the calculators can give you the values for a given angle of the trigonometric functions. So here's cosine, here's sine. The period of cosine, not surprisingly, is 2 pi. You go all the way around the circle. So at 0 we start here at 1, and if we come back, it'll be over here at 2 pi that it again comes back to 1, the x-coordinate. And no matter where you are, it'll repeat every 2 pi. Similarly, the sine has a period of 2 pi. Every 2 pi, it's the same value. And tangent looks a bit different. It doesn't look like a wave. And the reason it looks this way is because, remember, tangent is sine divided by cosine. And wherever the cosine is 0, the denominator is 0, the function is not defined there. So it goes off to infinity or negative infinity, and there's a vertical limit line at that point. And the period of the tangent is every pi. It repeats every pi, not 2 pi. And the other three are the reciprocals. Here's the secant, the reciprocal of the cosine. So it's 1 over cosine. Again, any place cosine is 0, it's going to have a limit line and go off to infinity. So here's secant, this whole section here. Let's try to get rid of that other part. So there's negative values, positive values, and it's an interesting graph. And then down here is the cosecant, so reciprocal of the sine. So whenever the sine is 0, it goes off to infinity. It's not defined there. Like the sine of pi, for example. It's 180 degrees. The y-coordinate is 0 there. and here's the cotangent. So it's important to have these visualizations of these functions so you have a better understanding of their periodic nature and how they can model many, many things in the natural world.